When we look at ancient monumental architecture, the modern reflex is to see a result of religious zeal and brute force. We imagine millions of tons of stone dragged through the dirt by armies of unskilled laborers to build static, symbolic tombs for dead kings. But that assumption is collapsing. New measurement technologies applied to these archaeological sites are providing a level of detail that was previously impossible to capture. Using LiDAR, CT tomography, and EEG brain monitoring, researchers are detecting complex structural patterns and site-specific resonances that are invisible to the naked eye. Ancient builders integrated scientific functions directly into their masonry, treating massive stonework as a medium for active engineering. This engineering operated across 3 specific scales. At the macro scale, architects tracked celestial mechanics and orbital alignments, using them to strictly govern massive urban layouts. At the mesoscale, they manipulated internal wave physics. Enclosed stone chambers were meticulously calibrated to control acoustic resonance and wave diffraction. And at the microscale, generations of empirical iteration allowed them to trigger specific chemical reactions, achieving nanoscale material properties that rival modern industrial standards. These builders operated without the modern standard model of physics, yet through rigorous, systematic observation of the natural world, they achieved identical physical results. Take the Great Pyramid of Giza. It stands as a prime example of extreme cardinal alignment. The base sides of the structure deviate from true geographic north by an average of less than 4 minutes of arc. That is an error margin of exactly 0.06 degrees. This geometric model illustrates how they achieved this without a compass, utilizing a surveying technique known as the fall equinox gnomon method. By placing a vertical rod on a perfectly flat surface and tracking its shadow tip during the autumnal equinox, an exact east-west baseline is established. Once locked, it is extended outward, scaling up through simple geometry to form the 13-acre square foundation. The sub-degree precision of the final monument proves that during the foundation phase, the construction site itself functioned as an active, scaled-up astronomical surveying instrument. This mathematical alignment extends beyond static geographic points to moving planetary bodies. Mesoamerican Maya astronomers meticulously tracked Venus's orbit and its exact synchronization with Earth's solar year. Tracing planetary positions reveals a precise orbital resonance. 5 Venus cycles equal exactly 8 Earth years, drawing a perfect 5-lobed pentagram over this period. Plotted onto a floor plan, these geometric intersections create 5 central nodes arranged in a quincunx pattern. Halfway across the world, completely disconnected from the Maya, the Khmer Empire independently encoded this exact same geometry. The central sanctuary of Angkor Wat features 5 towers laid out in this precise quincunx formation. Ancient architecture physically manifested orbital mathematics in stone, directly synchronizing the human environment with recurring cosmic cycles. Moving from light to sound, we find structures engineered to manipulate mechanical wave energy. A prominent example is the Maya step pyramid of El Castillo at Chichen Itza. The exterior features 4 staircases, each built with 91 unusually narrow stone risers. This specific ratio transforms the staircase into a physical acoustic diffraction grating. If you produce a single hand clap at the base of the staircase, the sound waves strike the risers and reflect back. Because of the microsecond delays caused by the depth of each step, the returning frequencies compress into a descending waveform. The pitch drops rapidly from 1300 Hz to 700 Hz, perfectly mimicking the chirp of the local quetzal bird. Regardless of whether the acoustic chirp was the primary design goal or an emergent property of the staircase geometry, the physical structure effectively acts as a highly calibrated acoustic mirror. Indoors and underground, acoustic manipulation becomes even more pronounced. The Neolithic Hal Saflieni hypogeum in Malta was carved directly into limestone around 3000 BCE. The chamber's curved walls and internal niches function together as a Helmholtz resonator. This geometry traps low-frequency sound, generating a standing wave that peaks precisely between 110 and 111 Hz. This diagram reflects modern EEG data recorded from subjects placed inside the chamber, showing that exposure to this 110 Hz tone triggers a distinct asymmetric shift in brain activity. Language centers in the left prefrontal cortex deactivate, while the right prefrontal cortex, which processes emotion, is heavily stimulated. Ancient builders utilized the high acoustic impedance of enclosed stone architecture as a physical tool to actively alter human neurobiology during rituals. At the microscale, early material science yielded results that outlast modern equivalents. Roman concrete infrastructure, like the unreinforced dome of the Pantheon and marine breakwaters, has survived highly corrosive environments for over 2 millennia. The chemical mechanism behind this durability lies in a hot mixing technique. Roman engineers combined volcanic ash with quicklime at elevated temperatures, intentionally leaving millimeter-scale, highly reactive lime clasts trapped inside the cured mortar. When structural cracks form, environmental water seeps into the fissures, dissolving the embedded lime clasts into a calcium-saturated solution. This triggers the growth of jagged calcium carbonate crystals that expand to bridge the fracture, permanently healing the structure and blocking water intrusion. By refining this mixture over generations of trial and error, Roman engineers developed a responsive, self-healing nanotechnology long before the underlying chemistry was theoretically understood. A similar mastery of molecular structure occurred in metallurgy. Southern India produced Wootz steel, a high-carbon iron export that Middle Eastern smiths forged into legendary, highly resilient Damascus blades. Iron was smelted in sealed clay crucibles, alongside plant matter and ores containing trace elements like vanadium. This thermomechanical process allowed smiths to strictly control how the iron absorbed carbon. When researchers examined 17th-century Damascus blades under modern transmission electron microscopy, they discovered that this thermal cycling forced the carbon to assemble into microscopic nanotubes and summon tight nanowires within the steel matrix. These ancient material scientists were routinely manipulating structural matrices at the molecular level, forging a composite metal with flexibility and impact resistance that baffled European foundries for centuries. These technological breakthroughs were not isolated anomalies. Across continents, completely disconnected empires independently developed convergent engineering solutions to solve universal physical problems. This schematic shows similar mechanical logic. While Greeks cut gears for eclipses, Zhang Heng used pendulums for early seismology. Inside his seismoscope, a weighted inverted pendulum ignored local vibrations, isolating primary P waves to indicate distant earthquake directions. Identical physical constraints, gravity, orbital mechanics, mechanical waves, and geology, forced distinct civilizations to systematically zero in on the exact same optimal mechanical and mathematical solutions. It is time to strip away the historical mysticism that often clouds how we view the ancient world. These builders were our empirical peers, reading and manipulating the physical world long before the first modern formulas were written. Viewing these monuments as a monumental laboratory for applied science shifts our understanding of what was possible long before the industrial age.